Hello बच्चों, let's read this question. According to Bohr's theory, hydrogen atom for an electron in the nth permissible orbit has following options correct. So for that, please note the key concept of this question, that according to Bohr's law, Bohr's postulates the angular momentum of an electron rotating in nth orbit must be the integral multiple of h upon 2 pi. So students, according to this postulate, let's say this is the electron which is rotating with velocity v, and this is having radius r. So the angular momentum can be represented as mvr. This must be the integral multiple of h upon 2 pi, where n can be 0, 1, 2. Now, according to Bohr's second postulate, the centripetal force required by electron is provided by the force of attraction between electron and nucleus. So we can write the force between nucleus and electron as k q1 q2 upon r square. This must be equal to F centripetal force, that is for revolving around circular motion. This electron is moving with velocity v, and this is nucleus. So the force which nucleus applies on electron, this provides the centripetal force for electron to complete circular motion. So F centripetal's value we can write mv square upon r. This must be equal to k into q1 into q2, where q1 is charge on nucleus and q2 is charge on electron. So charge on electron we can write E, and charge on nucleus we can write Z into E. This is because, let's say this is an atom of atomic number Z. So the number of protons it will have in the nucleus will be Z into E. The number of charge of nucleus will be Z into E upon R square. From here, R will cancel out R square, and we will left with kze square upon R. This must be equal to mv square upon R. And from here, we can derive the expression for v square, that is mv upon mv r nh upon 2 pi. From here, we can write v equals to nh upon 2 pi mr, and on squaring we will get n square h square upon 4 pi square m square r square. We are doing all these steps just to obtain the first option, that is dependence of radius on nth orbit. So students, substituting the value of v square in this equation, so k z e square upon r, this must be equal to m into v square m. From here we can write the value of v square n square h square upon 4 pi square m square into r square. Again, one r will cancel out the one r from this square term. So taking r to the numerator here, so r will be n square h square upon k z e square into 4 pi square m square. This will cancel out this square term. So we will left with n square h square upon k z e square into 4 pi square m. So students, h was Planck's constant. This will remain constant. K is 1 upon 4 pi epsilon naught. This is also constant. Z is atomic number, which is constant. E is charge on electron, which is constant. 4 pi square is also constant. And m is the mass of electron. This is also constant. So clearly radius is proportional to n square. So we can say that option A is correct. Now we have to check option B and option C. Momentum is proportional to n. We have seen in the key concept that according to Bohr's model, mvr is proportional to nh upon 2 pi, where mvr represents angular momentum, let's say p bar. This is equals to h upon 2 pi. H is the Planck's constant, this will remain constant, and 2 into pi is also constant. So from here we can say that angular momentum is proportional to n. From here we can say option B is also correct. Let's check option C, that velocity is proportional to n. Having the velocity expression, we will use the same Bohr's postulates, that is m vr, this must be equal to nh upon 2 pi, and the centripetal force required by electron mv square by r, this must be equal to the force acting between nucleus and electron. This was kZe square upon r square. So students, from here we can write the value of rs and h upon 2 pi into mv, and on here we can see that this r will cancel out this r square. So mv square equals to k z e square, and in place of r we can write nh into 2 pi m v. So we are left with m v square equal to k z e square upon nh into 2 pi m v, 2 pi m into v. So this from v, this will cancel out v square, and m will be cancelled out. So from here we can write v equals to k z e square upon n into h into 2 pi. Students, k is 1 by 4 pi epsilon naught. This is constant. Z is atomic number. This is constant. This represents charge on electron and proton. This is constant. 2 pi is constant. H is constant. So v equals to, let's say from all we can write k dash upon n. So from here we can see v is proportional to 1 upon n. But option C says that v is proportional to n. Clearly option C is incorrect. Now we have to check option D, that linear momentum. The linear momentum is defined as linear momentum. This is equal to m into v. So we can write T equals to mass into velocity, and velocity we have derived here kze square into 2 pi kze square into 2 pi upon n into h. So from here we can see m is constant, h is constant, k is constant, z is constant, e square and 2 pi is constant. Again we can write linear momentum equals to k dash upon n. From here we can see p is inversely proportional to 1 upon n, and option D says same. So option D is also correct. So how many options are correct? Option A is correct, option B is correct, option C was wrong, and option D was correct. So the correct options of this question is A, B and D are the correct options. I hope आपको ये concept समझ आया students. Thank you.